Hi, welcome to an Arduino tutorial from Robojax. In this video we are going to see how we can use this XYC-WB-D1 motion sensor module based on BISS0001 motion sensor chip. We will get the code for this project by clicking on the link in the description below, which will take you to robojax.com/learn/Arduino. Let's get started with this. So this is the module and that's the chip. I tried to put it at an angle that you can read it. BISS, that's 0001. This is the same chip that is used in this module, the main motion sensor that everybody uses for Arduino. And this is another version which is used the same chip, and this is mentioned at XYC-WB-D0, while the one that I have here, it's D1. People have put quite a lot of stuff as if this is microwave. There is no microwave component or anything. It's just simple. This is a circuit for that one, which I'm going to show you the data sheet next. And here is another version of it. So this has an inductor with this transistor to oscillate, but the same chip and the same functionality. This is another version of it. But this one has multiple outputs. One sensor, this sensor that you've seen it, very famous one. But this the chip, the module, inside there is another sensor that is for infrared, so it detects. In this module there is no infrared or nothing. It's just around 10 megahertz oscillator. As you can see, this is an inductor, and I've done quite a lot of looking and studying this and searching online to see what this is. On this side it's fully just a ground, so it can reflect the signal this way, and I've tested it. It can work about 6 to 8 meters. On the back side it covers with less distance, maybe around 2 meters, but on the front it goes far away and on the right side. So as I was looking for all the frequencies, some people have mentioned this as microwave or 5.8 gigahertz. All of those are just false. Here is one data sheet, or general description as they call it. This is not a data sheet because we don't know much about this, but it's just operating with 5 volts. And here are some of the pin and reference current and voltages. And as you can see here, FTB, the time base, is between 15 to 17 kilohertz, and typical is 16. And all these voltages and currents are mentioned. This is one of typical applications for this, which I'm going to show you next. This is the most informative one on this chip, BISS0001, and they use the word micro power, PIR. They use it because infrared motion detection. So pin number and also all these parameters, which we don't have to worry, but they say look at a schematic, and then we have TX and TI. So this value multiplied by 10. So this value 24,576 by R10 and C6, which I'm going to show you next. So this is retriggerable waveform, and this is one portion of it, the block diagram. As you can see, there is no high frequency and nothing. And here is, from this we can learn a lot, and show you now the waveform at this for this time constant. As you can see, C6 and C7. So this is C6, C7, and R10 and R9. So R10 and R9, these two are, because this RC are creating one time constant and this is another time constant, and we are going to look at the waveform in here and here, and I'm going to look at a waveform of this coil. To clarify, this is not operating with 5.8 gigahertz. I've tested this and I'm going to show you the waveform, and this doesn't have any other special sensor except just an oscillator that is generating electromagnetic field, and the magnetic field is being disturbed by a motion object, and it locks it back when there is no motion. Other than that, there is nothing fancy about it, but it works. The official name of this is XYC-WB-D1, but if you want to search and buy this from AliExpress or eBay, sometimes they put 5.8 gigahertz, or sometimes they list it as a human body detector, and majority of the time also they put BISS0001 is a R2C1 are used for TX, and then for TI R3 and C2. So these two are used here. For this, because we have the formula that it says 24,576 times R2 times C1, because we can read only the R from PCB, which is 5,200, this one 5,200, that's 5, 2, and then 2 mean the 2 zeros. And I measure the time that when it triggers, it waits for 10 seconds continuously until it goes off. So we have the 10 second and we have 5,200, then the capacitor, this C1 must be 27 nanofarad, and I did not remove to measure it. And the same thing, the formula is here, 24 R3C2 is here, and then we have the resistor and the time, so you can play with it if you need to do those things. And as you can see here, there is nothing special about this, no other special circuit, but it detects the motion. So C6 is determining this RC, this R and this C value, which are connected to pin 3 and pin 4. So let's have a look at the pin 3 now. This is the waveform of the pin 3. As you can see, it's 6.1 kilohertz. And that is the pin 4, which the waveform shape changes, same frequency due to that RC, the time constant. We look at the pin 5 and pin 6. So we can see the same type of time constant is also available here between pin 6 and this capacitor and pin 5. So I'm looking at pin 5. Nothing. And now this is pin 6. 6.137, so this is directly related to the pin 3 and 4. Then if we look at the this oscillator, this is a waveform. And this frequency is much higher. This is around 10 megahertz, 9.9. 9.19 megahertz. Now, when you buy the hardware, you will get this pin. When you buy this module, you also get this wiring, and this is the actual module with a connector. When I was testing it, because this is both sides female, so that was making it very easy for me to just connect DuPont wires here and then connect it to Arduino. So the PCB is 33.8 millimeter by 23.2 millimeter. To explain the wiring, it has only 3 wires here, and we have VCC, ground, and out. The out goes either high or low. It's not analog or variation of voltage. Right now this motion sensor is detecting, and we are getting 5 volts at the output here for this device, but I am not able to make it not detect. So when there is no motion, it should go to 0. Now I'm close to this and it will start counting. I'm going to reset it and show you the code. So detect start at 0 because I'm very close, and here is the code. We are defining the counter. This is for this counting purpose, nothing fancy. We're just putting 0, and then we set the buzzer pin 11. So it can be connected to buzzer or a relay if you want to trigger something else. So this pin can be used, and then we set buzzer pin, which is 11, to as an output, and then 9600 is this value that must match for the serial monitor, which you can bring it from here, tools, serial monitor, and then inside the loop we are just reading analog 0. I've connected this to analog 0, so the value will be as a V, and we check if V is equal low. So low means no detection, and then we set the pin as low, and we set the counter 0. And then if it's not low, it's high, then we count as 1, and then set the pin as 1, and then print this number here, and then after that you print the dash, and then detect it, this value. And then we wait for 1 second, and it continues. The loop continues like that. One thing not to forget is that this module within the closed distance, it will not work. So you need at least 1 meter or longer distance for this to work. So that's the limitation, because if you set closer, or even if there is no motion, it will always be on. So let me show you now. Now, because this sensor, as soon as you turn it on, it will start detecting, and when you work on this, you will never be able to understand if it has been triggered or not. So that's why I put the buzzers and left it and went further away to see if it was triggered or not, and that's how I detected it. And now I'm going to demonstrate that. The buzzer started, and then after any motion you have to wait at least 10 seconds before the next trigger happens. So for me, for this to work, I have to be motionless for 10 seconds. But as I mentioned, I'm very close to this, so it might not work, but let's try it. Okay, so it did not work. Demonstrate the device is silent. I'm not moving here. In this room there is a lot of those wiring and equipment and machines and computers, except the computer is beside this. So let me just move away from the camera, and this will turn on, and then within 10 to 15 seconds it will shut off again. You see, it started it. I'm going away. And now I'm coming back. Again, yeah, now it's sorted it. So that perfectly works. Thank you for watching. This was my test and review of this motion sensor based on BISS0001 chip. Please share the video and also subscribe so you can get updates of my upcoming video. Good day.